The purpose of this video is to go over Vernier's Graphical Analysis application, which is a nice handy application that's actually pretty intuitive to use. And we're going to be using it for our alcohol sensing lab, where we're analyzing the percent by volume ethanol inside a sample of kombucha. While it is really easy to use and it's intuitive, it's still worthwhile to see somebody go through the process. And so the point of this video is just, like I said, to show you the mechanics of data collection. Our overall goal here is to figure out how we can get a data point that's measuring detector response for a given solution. Okay. So what you're going to do is you're going to download the app, and as soon as you open it, this is the main screen that you see. Okay. I have a sensor nearby. I know you can't see it, but right now it's blinking red, which indicates that it's not connected to anything. To connect your device to the sensor that you're going to use, you're going to hit Sensor Data Collection. And what you'll see is a sensors box will come up. And at the very top, it says no devices connected. But you'll see at the very bottom, it has found a device through Bluetooth. Now, I'm going to make sure this is the correct device by reading the number after ETOH. The number is 12100P6. On the back of the sensor I'm holding, and again, I know you can't see it, but this will help you kind of figure out what you have to do in lab. On the back of the sensor I'm holding, right above the barcode, these numbers, these exact sequence of numbers, 12100P6 appears. And so now that I've confirmed that the sensor I'm holding, the sensor I want to use, is the sensor listed here, I'm going to hit connect. So now it says, oh, here are the connected devices, and we have this alcohol sensor now linked to our phone. Once we hit done, we're at the main screen associated with data collection. Right, so we don't really have to go anywhere else. We don't really have to go anywhere else. This is what we're going to use to figure out what the detector response is. So where is that information? Well, if you look at the x-axis, what we have listed is time in seconds. And if you look at the y-axis, it's listed as ethanol vapor percentage, but that's not technically correct. And what we're going to do, instead of taking that information as ethanol vapor percentage, is we're going to list that as detector response. That's what we're after. We're after detector response. So we are after the value on the y-axis, but we're going to list it differently. It's not going to be a percentage. It's literally just going to be a number that reflects the amount of vapor that the detector is detecting or sensing. So how do we actually go about doing the data collection? Well, at the very top, there's a button that says collect. So what you're going to do is you're going to have your sample prepared inside the plastic container that's associated with your alcohol detector. You're going to gently place the detector on that container, and then you're going to hit collect. The button will switch to stop, but you don't want to stop yet. Okay, so what has to happen is the sensor has to have surrounding it a saturated environment that's reflective of the amount of ethanol vapor produced by the solution. And that takes some time. So what you'll notice is you have this blue curve start to form, but it starts off very low. So what I'm going to do is use like 2 fingers and try to zoom in on it. Okay, so I did the normal like device thing where I used 2 fingers and I moved them apart, and I was able to zoom in on a different part of the curve. Ideally, what we want is this curve to level out, to flatten out, and to converge to a Y value that is definitely indicative of the amount of detector response, all right, associated with the sample that you're analyzing. That might not occur for all of your samples, and based off the time restrictions, with COVID going on, you're going to follow whatever your procedure says. Most likely your procedure tells you to cut this off maybe before it levels out, and that's perfectly fine. That's going to be accounted for in the graphical analysis that we're going to enact, so it's not going to introduce too drastic of an error into our analysis, and you're going to be able to then actually complete the lab and take enough data points to get a good fitting curve to what you're actually observing in the laboratory. This one's actually pretty stabilized already, actually. It's flattening out. You can see that it's probably not going to get quite to 1. It's definitely not going to get quite to 1. It's really leveling out, so this is a nice situation for data collection. Just to keep this concise, what I'm going to do is I'm going to take a measurement at 100 seconds. So I'm a little bit past 100 seconds, so now I'm going to hit stop. So here's how you record the actual value that needs to go into your laboratory notebook. Here's how you determine detector response. You're going to touch the blue curve, and you'll notice that it drops a vertical line to the x-axis. The x-axis gives you the time, right? And so what I'm going to do is, I decided that the time I wanted was 100 seconds. So I'm going to move the vertical line over to 100 seconds. The blue number that shows up next to the vertical line is telling you what the detector response is. It's finding the value on the y-axis. So in this case, with this sample, we would read this as 0.790, right? As a unitless detector response, okay? So it's pretty simple, it's pretty straightforward. But again, hopefully you find this useful to actually see. Now, the last thing I'm gonna talk about before I cut this video off is what you do between runs. So right now, the detector is being saturated with ethanol, right? It actually takes a little bit of time for it to get rid of that ethanol. So between runs, you don't want carryover of ethanol from one run to another. And so what I'm gonna do is I'm gonna remove the alcohol sensor, lay it down gently on the laboratory surface, and I'm gonna leave it exposed to the air, and I'm actually gonna hit collect. Now, I'm not hitting collect to actually collect the data point. What we'll see here, and I'll zoom way in, is I'll actually see the detector losing its ethanol. And ideally, this will come down to a constant value close to 0. So this is just to assure that, again, it's ready, it's fresh, it's good to go for the next solution you're about to analyze, and no residual vapor is going to carry over. And that's essentially it, okay? So as always, if you have any questions, make sure you read your procedure thoroughly, reach out to your laboratory professor, make sure you understand exactly what you need to do, all right? And again, if you have any questions, let us know.